us. We have an audience here full of wonderful people who are very interested in what you have to say. So let's just start. I'm going to make the questions kind of short so you can make your answers long. We can make the most of our time. Cassie, let's first tell the audience a little bit about yourself.
Well, I serve as Chief Decision Scientist for Google Cloud, and I've been at Google for just over 4 years. And when people ask me what academic discipline I feel most affinity with, I say statistics. I call myself a recovering statistician. But it's actually not a fair characterization to just put me in that stats bucket, since I'm very, very interested in decision-making of all aspects. And that encompasses both the disciplines that deal with the data sciences, the sciences of information, and what information we have and how to transform it into action. And then also the social sciences and managerial sciences. How should we be thinking about this? How do we take the human into account? How do we put all of this together? And in addition to that, there are other disciplines as well, the biological sciences, neuroscience, philosophy. All of these things are an interest of mine. So my academic background then ends up being 2 degrees in statistics, 1 in neuroscience, 1 in economics, and 1 in psychology. And as for the rest of me, I'm a lover of theater, the arts, and travel, and I'm really, really happy to be here to talk to you about decision intelligence.
Thank you, thank you. So let's get to just a very basic question. How would you define decision intelligence?
So I would call it the discipline of turning information into action. So everything about decisions, but decisions defined as broadly as possible. And so it has to then be the intersection of every science and every discipline that has something to say specifically about that transformation of information into action. And I prefer them best when there is a bent of doing that all usefully. So turning information into improved action rather than worse action. But I suppose that one can feel free to study every aspect, including how to make things worse. But it would be a discipline that really restarts thinking about decisions, understanding that maybe as all these disciplines that might contribute to the space grew up, they all grew up in separate camps. So in the same way that biology once used to be part of philosophy and then splintered off and became its own thing where that was more appropriate, I imagine that there are aspects of all these disciplines, psychology, economics, neuroscience, statistics, that all grew up in their parent discipline, but if put together into its own umbrella, could all become bigger and more powerful than just the sum of those parts. And also that a lot is being lost if there are silos between these disciplines that exist only based on how they have historically grown up. So if we were to start again and we were to say, let everyone who has something to say on the score of how to transform information into actions in a better way, put their knowledge together, that repository of knowledge, that would be decision intelligence.
So it sounds like that actually kind of gives me an answer to the next question, which is what is the importance of decision intelligence? And so you might want to expand on that. But I'm also really curious about the special relationship of decision intelligence, or AI and DI, in tech companies as opposed to in other fields. So maybe you can speak about that a little bit.
Well, so first off, if we're going to think about something like transforming information into actions in a better way, at scale, with all the technology that's available to us today, so let's speak to the importance of that first. That is a huge thing. What we now know how to do, automate certain aspects of decision-making with AI and machine learning, that's incredible. And that's incredibly powerful, and we could really improve our lives with that. And not just at that tech company level, but individuals can now start doing this because of all the infrastructure that humanity has built. Things like the clouds mean that you don't need to go and build your own data center if all you would need is an hour's worth of time of a data center running. So instead of having to go do it all yourself, you can borrow that technology, use it, get a lot done. As an individual, as a small company, as a non-tech company, you don't have to have all that knowledge of how to do all those pieces yourself. So this gives us a powerful set of perspectives, and all those powerful data science tools, all augmented by those social science and managerial science perspectives and others. And that is now usable, not just by tech companies, but by pretty much everyone, because that infrastructure is shared. So while tech companies might be the first to try out some of these new directions, this should be a discipline that's highly relevant to everybody. So I'm hoping actually that it ends up with no special role in tech and becomes something that everyone can use, perhaps in different ways, just like a discipline like economics or psychology would be used, applied, studied differently for different purposes.
Great, okay. So that's a little bit about how it would be outward-facing. So inward-facing, talk to me a little bit about the relationship of AI, DI, and engineering.
What do you mean by inward-facing?
Sorry, so artificial intelligence and decision intelligence and its special relationship to engineering and an engineering company, and how those two complement one another or work together, or how it's the natural progression, and is it just the engineering, or is engineering in people, or, you know, talk to me a little bit about that.
Well, this is fundamentally an engineering discipline. So it will be part of working with engineering. There will be engineers involved. So, but it really depends on what sort of information interaction project we're talking about. So if you, as a business leader or decision maker, start thinking through a particular decision or problem or something that you want to do, some information interaction context, it may be a case where what you best need help with is how to think through the information, the qualitative information that you personally have, and think about potential human biases, and think about how to make this decision that you already have just in your own head enough of the pieces of, to put that together in a way that will be informed by cost-benefit analysis from economics, heuristics and biases thinking from psychology to understand your own heuristics and biases and make sure that they don't trip you up. You would use those perspectives because you would first diagnose that that's the class of decision that you're making. You wouldn't even involve engineering. You would have the tools, because you are a leader trained in this sort of thinking, to just on your own make a decision in a better way, combining multiple disciplines already. So this isn't necessarily a department, right? It is like economics or psychology. It is a discipline. It's a field of study. You might know different parts of this. Any given individual might have studied different aspects of this, and so that's one application where a business leader doesn't even need an engineering team. It's a set of tools that they would personally use. For another kind of project, say you are building a very large AI system that is going to do something like identify whether or not there is a cat in a photograph, right, to be used for something like Google Photos, right, real legitimate system. Then that is a much bigger project, which will, of course, have a lot of engineering involved with it. It'll have engineering on the data engineering side, which will be one step in this process. So we're thinking about information, turning information into action. How do we get that information? The actual information that lives on a disk somewhere. There will also be an aspect of, as the team is framing all these problems, how are they, the humans, processing their human inputs? But they'll also use data like photograph data to train the system. How do we move that data around? How do we do that at scale? So that's all data engineering. There will be a heavy engineering contingent that understands how the baton is passed to them from leadership and who can pass the baton on properly to the analysts who are also going to be housed in engineering, but they write code to a different purpose, who will then start doing things like thinking about how we pre-process such data, how we clean it up, how to best feed it into the machine learning engineering process. Those are engineers as well. Then once the prototype of such a system is created first time through, you have to get a prototype like that into production. You have to think about how to do it reliably so that the system doesn't just crash and then you open Google Photos and then there's no Google Photos there, and it has to integrate with everything else. And those reliability engineers are engineers. And then there's the actual software engineers who make this system run efficiently and well at scale and integrate with all the rest of the platform. So there is a lot of engineering at every stage of that heavy engineering project, which is essentially an information into action project. Yeah. Now, how that is all organized and arranged, who does what in what order, and how can we improve the standard data scientific process with the decision scientific perspective, that's where the extra magic happens. But typically, when it starts being something that actually uses real data, there will be engineering involved.
So tell us, think just a little bit about like 5, 10, 20 years ahead from where you are right now. How do you see decision intelligence evolving? In what ways and in what uses? And where do you think the importance lies out in the future for us?
Yeah, so I think that's something that is happening that's really, really exciting. And I think it can be a great focal point for reasoning through potential future directions, is the fact that all the tools are becoming easier, and that the research algorithms are also becoming more readily available. So if you think about technology 10, 20, longer years ago, if you want it to be at the cutting edge, you tended to have to know how to do all the bits yourself. It was less a case of putting together very sophisticated Lego pieces and a little more of reinventing the wheel. Now we're moving towards really super sophisticated modular Lego pieces, if you will, where putting them together is becoming something that you don't need advanced degrees in. The tooling is getting much easier. To think about a very good example of this, I think, is what it takes to visualize data and what it takes to make really beautiful data visualizations. Think about what that used to be like in the past. Really, really hard to do. Now you get these suites of things where you can just grab someone else's script off of GitHub or however you want to go about this, and essentially you run it and you get all the different kinds of plots, or you get your dashboard in a box, or you get these beautiful, interactive, shiny tools. You don't have to write that yourself. Your company doesn't have to do it. You just sort of pick that up off the shelf. So much of it is even open source. It's great. So now you don't have to learn how to do those bits. You can start using them. And when you start having access to these things and you can just start using them, now it gives you the space to sort of sit back and think, well, what am I using them for? And what's worth doing with all of this? Because you're freed now from that minutia, that nitty-gritty of building it all from scratch. So you can do a lot more, but now it becomes really important to think about what that means and how you're going to use it. And you can also do things at much larger scale. So it's not limited to what you can do with a laptop. You can, for example, run something in the cloud, and all of a sudden what you could never have done as an individual is absolutely available to you. And you don't have to build a data center to do it. So that means that humanity is going to have more opportunities for individuals or small teams to be really creative, to do cool stuff, to see their creativity come to life. To do that well, it would be good if they had a series of processes or tools to make it more likely that they are successful with that and that they develop things safely and reliably. Anyone who's been in data science and has implemented data scientific solutions at scale will know that you can have some rather unfortunate results if you're very, very meticulous at carefully getting data and carefully applying math to solve entirely the wrong problem. Or if someone along that process didn't quite do their job right, or didn't think something through. But there's no good tools and there's no good principles that really connect all those aspects together. And that's what decision intelligence is trying to do. So as the individual bits along that journey all become easier, I think we will shift. The world will shift towards caring more about how everything is glued together, towards seeing that whole holistic thing. And when they start looking there, I hope that we, all of us who are here at this conference, virtually or in person, would have done our part to give them something to turn to that they can actually use, that will actually make this journey of theirs easier. That we don't need everyone from scratch trying to figure out how you actually run such a project or how you solve a particular kind of problem. So my vision is the holistic approach becoming much, much more important as the tools become easier, so that the engineering nitty-gritty is less, is a much smaller part of projects. So everyone can do more with less, and now we have to care more about how they're doing it and what they're choosing to do.
Okay, I'm going to do one last quick question for the audience for you here. So we have a lot of people in our audience today. How should they think about integrating decision intelligence into their work, into their lives, and maybe any key takeaways you might want to share with the audience?
Sure. So when it comes to work, a very natural place to start thinking is data science itself. And data science it's a hot thing right now, let's all admit it. There's a lot of excitement for it. But what I want to propose for your thinking is that data science is the middle part of a process. And there are bookends around that, which, if those aren't done well, data science may as well not be attempted. There's this notion of a type 3 error in statistics. So if you remember your stats course, quick refresher. So type 1 error is where you incorrectly reject the null hypothesis. Type 2 error is where you incorrectly fail to reject the null hypothesis. And type 3 error is where you correctly reject the wrong null hypothesis. So that's a sort of joke in some sense, that phrasing. What it means in English is you meticulously, correctly, carefully use all the right math to solve the wrong problem. And what decision intelligence is going to help you with, in addition to managing that end-to-end process and getting your team aligned and having everyone contribute so that the whole thing works well, is to ensure that you reduce that type 3 error, that you stop sending meticulous data investigations down the wrong rabbit hole. Now, one of the ways that you change to a decision intelligence mindset is that you have to start with the decision. What are we trying to do here? Are we trying to make a decision? Because that will influence how you should go about your project. What's happening right now is people actually think about it in the wrong order. They pick their algorithm or their mathematical method long before they think about how they actually want to act on such a thing. And if you are agreeing to make no decisions based on these data, so you're just going for inspiration, just some little bit of data mining, that's okay, that's fine. There is a process for that also. And you shouldn't take your results seriously, and that comes with the territory there. And I don't have time to go into the long explanation of why you can't use the same data point for both inspiration and a rigorous assessment of decisions. But in any case, if you've chosen to just simply get inspired but not make decisions, there is a process for that, and that happens to not be the one that you learn in the statistics course that teaches you inference. If, on the other hand, you want to make decisions, now we want to think about how many decisions you want to make, because that will determine, again, what you're trying to do. You can use the same algorithm for a project involving statistical inference, which is few or one important decision under uncertainty. Use the same algorithm from that for a machine learning application, which is to make a recipe for repeated decision-making under uncertainty. However, even though the math is the same, the way that you carry out the project, the way that you test whether the project is successful, all the things that need to be done for that project, they are different. And the starting place, the first thing that you need to deal with before you can get to any of the other stages is, what class of decisions am I dealing with? Because from there, you're going to build out the process. So that's where to start, and that's how to start integrating it, both at work, where you now want to start seeing all of your projects through the lens of decision-making. And then also in the personal lives, where you want to have the literacy to interpret other people's data scientific endeavors. You want to know whether you can take that as mere inspiration or whether you yourself can base a decision on that. You want to think about how information may be used to manipulate your actions so that you can make yourself immune to those manipulations. To think through what you should believe or not believe when reading scientific studies, when reading articles. So this is a literacy that can help you out even if you're not implementing these large end-to-end projects. And then I forgot what the last bit was. What was the last bit?
Oh, just any takeaways you might have for the audience. That was actually a very good explanation of how to integrate it into our lives.
Yeah.
Any takeaways you think that are helpful?
Yeah, the final takeaway, I think, is really that this has to be about a restart, a start from scratch. To have a Sorry, let me start that again. There are boundaries up between disciplines right now. We are still, many of us, thinking in terms of, hey, are you an AI person? And are you a stats person? Are you an economist? Are you a psychologist? We need to have a concerted effort to put those boundaries down and to say, look, this is going to be a discipline about turning information into action, a practical discipline of that. And we really need to include and invite anybody who knows something about this and allow them, if they wish, to consider themselves a part of this. And so we really need to focus on bringing everybody in and really saying, hey, humanity, let's figure out what we jointly all know about decisions. There's a lot. And it works better if we get all the different perspectives. They really multiply one another. So now is the time to really ask people, get their perspectives, bring in as many of us as possible.
Great. Well, thank you so much. You've helped us do that today here with our audience, so we really appreciate you coming, and we're very much looking forward to seeing how your position evolves over the next year, and hopefully you'll be here next year in person and you can tell us about it yourself. Thank you for coming.
Yeah, I hope so. Thank you very much.